A script that runs once is a script. A script that has to run every day for months without a human babysitting it is a pipeline, and those are completely different animals. The script only has to work when the network is clean and the site behaves. The pipeline has to survive the network being flaky, the site changing overnight, and a run dying halfway through with half the data already written. Today, I want to walk through how I build scraping pipelines that keep running through all of that using orchestration tools like Dagster and Prefect. I run production scrapers for a living, so I have been paged at 3 in the morning enough times to build for failure on purpose. I am going to keep this practical. The goal is not a clever scraper, it is a boring one that recovers from problems on its own and only wakes you up when something is genuinely wrong. That reliability is not in the parsing code, it is in the structure around it, and that structure is what an orchestrator gives you. Fingerprinting. An orchestrator turns your script into a set of connected steps it runs on a schedule, and it remembers what happened. It knows which steps ran, which failed, which produced data, and it can retry the ones that broke without rerunning the ones that worked. That memory is the whole point. A plain cron job runs your script and forgets everything, so a failure means starting over. An orchestrator lets you recover from exactly where it broke. Split fetch from parse from store. The first structural move is to stop writing one big function that does everything. Split the work into stages. One stage fetches raw pages and saves them untouched. A second stage parses those saved pages into clean records. A third stage writes those records to your database. Keeping them separate means that when the site changes its layout and your parser breaks, you have not lost the fetched pages. You fix the parser and rerun only that stage against data you already have, instead of hammering the site all over again. Idempotency is the whole game. Here is the idea everything else rests on. Every stage should be safe to run twice. Running it again with the same input should produce the same result and never create duplicates or corrupt what is there. That property is called idempotency, and it is what lets an orchestrator retry freely. If rerunning a stage might double your records or half write a file, then retries are dangerous and you cannot automate recovery. So you design each step to be repeatable from the start, usually by keying records on a stable ID and writing in a way that overwrites cleanly rather than blindly appending. Checkpoint so you can resume. Long jobs need to remember their progress. If you are pulling 100,000 pages and the run dies at page 60,000, you do not want to start from zero. So you checkpoint, write down what you have finished as you go, and on the next run, read that and skip what is already done. An orchestrator helps here by tracking which chunks of work succeeded, so a restart naturally picks up the unfinished ones. The difference between a pipeline that checkpoints and one that does not is the difference between a 5-minute recovery and a 5-hour one. Retries with backoff, done right. Failures at the network layer are constant, not rare, so retries are not optional. But a naive retry that fires again instantly just hammers a struggling site and makes things worse. The right pattern is backoff. Wait a moment before the first retry, then wait longer before the next, giving the site room to recover. Both Dagster and Prefect let you set retry counts and delays per step. So a single flaky request quietly succeeds on its second or third try, and only a request that fails every attempt gets escalated as a real problem. Not everything recovers, and you need a place for the failures to go. That place is a dead letter queue, which is just a fancy name for a list of the items that failed all their retries. Instead of crashing the whole run because 10 pages out of 100,000 refuse to load, you set those 10 aside, finish everything else, and deal with the 10 later. This keeps one stubborn page from taking down a whole night's work, and it gives you a clean record of exactly what needs a second look in the morning. Incremental beats full every time. Do not rescript the world every day. Most sites change only a little between runs, so pulling everything from scratch each time wastes your resources and pounds the site for no reason. Instead, run incrementally. Track what you have already collected and only fetch what is new or what has changed since last time. This is lighter on your infrastructure, far lighter on the site, and it is the difference between a pipeline that scales and one that gets slower and more fragile as your dataset grows. Full rescrapes should be the rare exception, not the daily habit. Fab can malware and what this firms a basic venture. But sometimes you do need to go back and reprocess history. Maybe because you fixed a parser or added a field. That is a backfill, and a good pipeline makes it painless. Because your stages are idempotent and your raw pages are saved. You can rerun the parse stage across a date range and rebuild the clean data without touching the site at all. Dagster, in particular, is built around this idea of reprocessing ranges of data. Designing for backfills from the start means a schema change is an afternoon, not a crisis. Observability, or you are flying blind. You cannot fix what you cannot see. A pipeline that runs silently is one you do not actually trust, because the first sign of trouble is stale data days later. So you instrument it. Log how many pages you fetched, how many parsed cleanly, how many landed in the dead letter queue, and how long each stage took. Both orchestrators give you a dashboard of runs, their status, and their history. When the parsed count suddenly drops to 0, you want to see it on a screen that hour, not discover it when someone downstream asks where the data went. Alert on the right thing, but do not alert on everything, or you will train yourself to ignore the alarms. A handful of failed pages is normal background noise and should never wake you. What should wake you is a signal that the pipeline is actually broken. A whole run failing, the success rate falling off a cliff, or 0 records produced when you expected thousands. Tune the alerts to the shape of a real problem, not to every hiccup. An alert that fires constantly is worse than no alert because you stop reading it. Dagster or Prefect, briefly. So which tool? Both are solid Python orchestrators and either will serve you well. Prefect leans toward being lightweight and flexible, wrapping your existing functions as tasks and flows with very little ceremony, which makes it fast to adopt. Dagster leans toward treating your data as first-class assets, with strong support for backfills, typing, and knowing exactly what each step produces. For a script heavy on reprocessed Sandicing history, I tend toward Dagster. And for a simpler, flexible flow, I reach for Prefect. Neither choice is wrong, so pick one and build. A Prefect flow in a nutshell. The shape is small. You mark functions as tasks, give them retries, and wire them into a flow. That is a real pipeline skeleton, retries and all, in a handful of lines. Validate, or you fill the database with nulls. The failure that hurts most is the one that does not throw an error. A site quietly renames a field, or starts returning an empty value where there used to be a price, and your parser keeps running and writes rows full of nulls. Nothing crashes, so nothing alerts, and you find out days later that your data is hollow. The defense is validation. Check that the records coming out of the parse stage actually look right, that key fields are present and in a sane range, and fail loudly when they are not. A pipeline that trusts the site blindly is one that will fill your database with garbage and never say a word. Test on a small slice first. Never point a fresh pipeline at the full job on its first run. Run it against a tiny slice, a handful of pages, and watch every stage do its work end to end before you scale up. It is far cheaper to find a broken selector or a bad write on 10 records than on 10 million. I keep a small sample run I can fire on demand, so after any change I confirm the whole pipeline still flows cleanly on a few items before I let it loose on the real volume. The small run catches the mistakes, the big run would make expensive. Keep secrets and config out of the code. One more thing that separates a script from a pipeline is where the settings live. A script has the URLs, the credentials, and the rate limits buried in the middle of it. A pipeline pulls those out into configuration, so you can change the schedule, the target list, or the proxy pool without touching code and redeploying. Both orchestrators have a clean way to pass configuration into a run. This sounds like housekeeping, but it is what lets you run the same pipeline against 10 sites or hand it to someone else without rewriting it every time something small changes. Keep the site happy at the pipeline level. Politeness is not just a per request setting, it is a pipeline property. The orchestrator controls how many workers run at once and how fast the whole thing moves, so it is where you enforce a rate the site can absorb. Spread the load across time instead of firing a huge burst. Cache aggressively so you never fetch the same page twice, and prefer an official API or bulk feed when the site offers one. A pipeline that runs gently is one that keeps running because it never gives the site a reason to shut the door. The honest limits, let me be straight about what this does and does not do. Good orchestration makes a script reliable and recoverable. It does not make it welcome where it is not, and it does not change what you are allowed to collect. Public data, a robot's file respected, an official feed preferred, a gentle pace held. Structure buys you uptime and sane recovery, not permission. And no pipeline survives a site that genuinely does not want to be scraped, nor should it try to, because durable data work lives on the compliance side of that line, not in a fight with it. I run these pipelines in production every day, real orchestrated scrapers that recover on their own. So this is the structure I actually rely on, not theory. If you want the full versions, the written guides with working Dagster and Prefect setups, the idempotency patterns, and the retry configs are at dataresearchtools.com, with real code and no undetectable promises. Reliability is the boring part nobody films, and it is the part that decides whether your data is still flowing a year from now. So, to recap, split fetch from parse from store, make every stage idempotent so retries are safe. Checkpoints so you can resume and retry with backoff instead of hammering. Set failures aside in a dead letter queue, run incrementally instead of rescraping the world, design for painless backfills, and watch the pipeline closely enough to alert only on real breakage. Build it that way and it keeps running while you sleep. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.